So I think that we can start. It's 12 o'clock. This is a RADEXT extension, Radius extension working group. And if you miss the room, then you have time to switch it. And today, this is a note well. I think you know this very well, just to remind you. And this is a living code of conduct of IETF. So please be polite, stay on topic, and so on. So meeting details. RADEXT chairs are Margaret Collin. She's remote, and Valery Smyslov, I am on site. Hi, Margaret. And our AD is Paul Wouters. I don't see Paul in the room. Well, okay. And here's some useful links for you. And we have to do some administrative tasks. First of all, we need a note taker, and at least one, at better if there are two note takers. So any volunteers? Okay, thank you, Hannes. And then we have a short session at this meeting. It's only 60 minutes, so it's full of agenda full for a lot of presentations. So I think we won't spend more time for administrative tasks and just start presenting. So it seems that Click It doesn't work, so I can change the slides if you take.
Okay, thank you. Yeah, so radius DTLS-Bs, making radius DTLS a proposed standard, and the finish line keeps moving away. It was inside once, maybe it's inside now as well, but it keeps moving. Okay, so next slide. We had some progress since last IETF. There are 3 new draft versions. So the first new draft version with some fixes for most of the issues and pull requests that we had opened in GitHub, and that was in May. Then we had some discussions on the mailing list on most open issues that were still there. Then we had a second draft version just before the draft deadline for this meeting. And then we had some ongoing discussion on the mailing list, and we talked among the people who are here for the hackathon, and I published a third new version just at the end of the hackathon, so we have a common basis for our discussions in the data tracker and not just on the GitHub repo. Next slide. So what issues were resolved, hopefully? So for DTLS session tracking, the tuple versus the suggested connection ID, we added a sentence with a warning regarding IP address-based policies, because if you use connection ID session tracking, then you have to make sure that the client doesn't suddenly run out of a network area where it's not supposed to be anymore. The spec already allows using a different but equivalent session tracking method than the 5-tuple that we have in the document there. Now it's more explicit, and we have this reference there. Regarding the usage of common name for certificate validation, there was the issue that CN is only forbidden by the service identity BCP for server certificates. So after some discussion, we decided, well, I put up new text saying, well, okay, using the common name for validation is forbidden for servers. Clients can use the common name if they want, but if they are configured with a domain name or an IP address or an IP range, then they must use the appropriate subject alternate names alternative names in the certificate instead of common name. We added a sentence regarding the use of different clients that do both radius UDP and some do radius TLS or DTLS behind a NAT, because the server might not notice when a previous DTLS client now changes to radius UDP. This may cause some operational issues. And we changed the 4-tuple for session tracking to 5-tuple with just the protocol fixed to UDP. So we are consistent with usual literature in session tracking methods. So we have the 5-tuple of source IP and port, destination IP and port, and the protocol, and we just define protocol is always UDP. Then, next slide, we have the open issues, which are the DTLS retransmissions, retransmissions in general, and accounting delay time versus event timestamp. I'll go over them quickly en bloc, and I think then we can do the comments, questions about this at the end. So next slide. DTLS retransmissions. The current spec requires that the server reprocesses the retransmissions of cached responses through the DTLS stack. So we cache radius responses instead of the DTLS record that has the response inside. And we have no specification on how the client should behave on retransmissions of a radius packet. When looking over that, I noticed that the DTLS 1.3 RFC mandates that lost messages must be resent using the same epoch and keying material. So this is probably a thing that we should look at, and we need input from DTLS experts what we should do. I was told that this might not even be an issue. So DTLS experts, please tell us what to do. We don't know. Then the next issue is for transmissions in general. You can go to the next slide. Yeah. So retransmissions and their need, what should be allowed, what should not be allowed. That's an interesting thing, because retransmissions itself are forbidden in radius TLS due to the reliability of the transport, but resending the same logical information on application layer and not on transport layer might still be a good idea. For example, hey, I have an accounting stop packet and I really want the server to know that the session now has ended and the server wasn't responsive in the last 30 seconds. Maybe it's responsive an hour later. That should still be permissible to transmit it over the same connection. The question is the text in the current spec clear enough? Do we need to change something? Is this even in scope? Because this issue might not be unique to radius TLS and DTLS, but maybe a general radius issue. So there's that question. And then next slide for the last part. We have the accounting delay time versus event timestamp discussion on the mailing list. Currently, we discourage the use of accounting delay time if radius TLS, DTLS clients originate radius traffic, so not for proxies, but only for true clients, because the accounting delay time makes an assumption that the transport layer has a negligible delay. So this is not true for TLS, because the underlying TCP may have a considerable delay in transmitting a packet, whereas UDP, either you get the packet or the packet is lost. So there is some change in the underlying transport, or in the assumptions on the underlying transport. And if the accounting delay time is changed with every packet that is sent or retransmitted, then even reusing the same ID to signal, hey, I don't care about the old packet anymore, works for maximum 2-hop proxy chains, but since the proxy in the middle may use a new radius ID for the next hop, if we have more than 2-hop proxy chains, it causes or may cause congestive overload scenarios. So we instead recommend event timestamp that stays constant across retransmits. Transport delays are not important because I have we have a constant reference, and we don't care about transport delays anymore. So for right now, I don't see any argument in the mailing list against leaving the current text in as is, any substantiated argument. So I would suggest leaving this recommendation against usage of accounting delay time in. The current spec allows it, it just doesn't, it just discourages it. Okay, and with that, I think I've covered the open issues. Then I think I have the slide of what else is done, but I think we can go to the open questions and see if anyone has opinions about these.
I think I'm first in the queue. I think well, we wanted to go to working group last call right before this meeting and do a 4-week one, but we got feedback on the document before we could issue the working group last call, which makes it's slightly rude to follow feedback on a document with the last call before you've even answered the feedback. So that didn't quite work out, and with substantial feedback that Jan-Fred has just gone over. We need to get to the point where we have every issue that exists in this document on the books. Okay, so what we would like to do, and like feedback on this as well as the technical issues, is go to working group last call right after there's enough time for people to travel back from this meeting. So probably something like Wednesday of next week, and get all the issues on the table at least during that period, even if we're still talking about a couple of these issues. And then we would like to, I don't know if that was our only note taker who just walked out of the room. So did we get 2, Valerie?
I think that we can start working group last call right now. We just
Valerie,
prolong it, make it longer.
Taker just walked out of the room. No, he walked up there. He's good. Okay. So the question is, in addition to whatever technical comments you want to make, if people have opinions on whether it would make sense to just go to working group last call right after this meeting effectively, I would be interested in getting that feedback as well.
So any feedback can be received during last call too. So I think that as far as I know, and we discussed yesterday on the hackathon with Alan and Jan-Fred and Fabian, we see no issues, no essential issues with the current draft. So if some people find uncomfortable with the current text, they will have enough time to comment during last call if we make last call 4 weeks long. 4 weeks long is enough for all people to return from IETF to rest, because I think we should not wait more. We should start doing last call. And if there are any outstanding issues appear, that I am very skeptical that any real issues appear, that they will be addressed during last call. Your opinion?
That's my opinion. I'm interested, I guess, if anyone in the group has a substantial objection to that. And if you don't have to say anything, and we'll go to last call.
Okay, Alan?
Yeah, I think that's a good plan. We also have the issue that the deprecating insecure practices document will be published at the same time as this one for a number of reasons. And that has serious security issues for the rest of the Radius protocol, which people may or may not be paying attention to because it's not a standard. Separately from that, I think there was a lot of discussion in this about this document for accounting delay time. That really does belong in this document in some sense, because this document is affected by the issue, but I think a larger discussion of the issue probably should be in the proxy BCP document, which I hope the working group will accept, because that's just another one of these. Here's a list of everything wrong that does or does not work, and here's what to do about it. And I think it's probably best with a proxy BCP rather than trying to address client or server specific issues.
Heike.
Yeah, hello, this is Heikki. There is one thing that I just recently did, like yesterday evening, sort of a last minute miracle. So I tested RADEXT with certificates that use these post-quantum encryption, let's say, protocols. So just for testing, I first used a normal easy or elliptic curve certificate. So that gives about 14 to 16 IP level messages and transfers about 6 kilobytes of information when it does the handshake. And then I create a certificate with a public key algorithm MLDSA 87 and did the same test and got about 50 plus minus some messages and 31 kilobytes of transferred data. So in both cases, they are half and half, so 15 and 15 in both directions. And what comes to certificates, so the easy certificates are about in this packed DER format. The certificate is about 388 octets and private key 174, and the MLDSA counterparts are about 7 and 5 kilobytes. So there's a lot more traffic going over the wire when RADEXT is used with those kinds of certificates, but it really doesn't seem to affect anything. You don't need to configure anything different. It works like it used to work, but it just creates a lot more traffic, both in octets and both in messages. So that's just something that I just did. I'm not that well into public post-quantum things, but just a quick experiment. But what I think is that if we use correct kind of certificates and recent enough TLS stack, it does mean that RADEXT is also PQ safe. Am I correct? So that's my sort of a quick summary of the experiment I did. I can post all of this to the mailing list and write it to Wiki and so forth, but it is just something that I just did now, and I only have the notes, but I can put all the relevant information to the Wiki and mailing list also.
Thank you for letting us know, and please share this in the mailing list. I think it's in interest in the results.
Yeah.
So responding to what Alan was saying earlier, it's a complicated thing in Radius, of course, because the original protocol did not cover proxies at all. And so we have, and I think probably still when the original RADEXT documents that these documents were based on were written, they really didn't talk about proxies. And there's actually a lot of subtlety to proxying, not UDP to UDP or TLS to TLS, but the particular case that's difficult is when you've got proxies that are going between TLS and UDP. And I do think there's going to have to be work on that case, that we're going to want to talk about what best practices are in that case. And what has to happen to avoid any concern about downgrade attacks and so forth. But I don't think it makes sense to try to put it in this document, all of it, which is an update to existing documents that we were trying to move from info to, or experimental maybe, to standards track. I do think it makes sense to put it into the proxy document that Alan has started, or in a separate document. Exactly how the documents are structured is not important, but I do think it's important that we write that up. I think it would be a mistake to try to put all of that complexity into this document, which is trying to define the TLS only hop by hop protocol. That said, what we do in the hop by hop has to be here. So are we allowed to put this attribute? Are we allowed to put that attribute, etc.? But we don't, I think, want to try to put their like MTU issues with moving from TLS to UDP and back, for instance, and other types of issues that I think we really want to put in a later document. So I want to support what Alan said about putting that complexity into a later document. But I also want to emphasize that I think it is important that we publish that later document, because without it, we won't have any advice about this stuff at all. And there are some choices that could make this go very poorly. So that's it.
Just for my clarification, so you're suggesting that we remove the accounting delay versus event timestamp again from this document, or?
No, I think we should leave what's in here if it was already in the previous document, except we should clarify it and make it right. And that's really a hop by hop thing. Are we going to send accounting delay? Are we going to send event timestamp? It's a hop by hop question. But I think we need to be careful where we draw the line, because some of the stuff about retransmissions, for instance, is complicated, because there's some stuff in here about what proxies should do with retransmissions. And I'm not even sure it should be in here, because proxies need to behave differently about retransmissions with respect to whether they're proxying TLS to TLS or TLS to UDP, for instance. There's subtleties there.
Okay, Q.
Hello. So I can provide some insight on the DTLS retransmission stuff. So DTLS provides a retransmission mechanism, which is of its own packets. There can be separate from this a application level, let's call it retry mechanism. So the wording in DTLS about retransmitting in the same epoch is when DTLS of its own accord decides to retransmit something. If the application layer decides due to a timeout to retransmit something, then DTLS just treats that as a new packet. So that hopefully clarifies what should be going on.
Okay.
Yeah, as I explained to Alan and Valerie in before the start of the meeting, so there's in moving from TLS to DTLS, certain sort of, it's not just about the switch of the transport, but the handshake itself has to be transmitted reliably, and it's a lockstep protocol. So that required some additions, like the acknowledgements and so on in DTLS 1.3, or like the whole processing of these messages, the sequence numbers being added to the handshake and so on. So, but that's the handshake. And there, of course, are post-handshake messages which are exchanged after the initial handshake. So those need to be transmitted reliably. That's where the text about reliability and retransmission comes into the picture. For the application data, that's where the application is responsibility for any retransmission if it thinks it needs to do so. DTLS doesn't do anything there. What DTLS can optionally do is detect whether a packet was replayed by, for example, someone intentionally or unintentionally. You can use that, but if it detects that there would be a replay, or something. Nothing would be done by DTLS at that point in time. So every time, so if you radius for whatever reason decides to retransmit a packet, it would look for DTLS, it would just look like there's a new request coming in. It doesn't know that this was something that was done in the past and now it's retransmitted. DTLS doesn't know anything about that.
Okay, because the text I read was in the section for record layer.
Yeah, but it was referring to the reliable transmission of the handshake messages, and I will clarify that if that text was misleading in the BIS version of the document. Okay, so basically we can we can do even epoch changes and still retransmit the same. Okay, we shouldn't worry about
changes stuff. Is DTLS doing its thing? You should leave it be and let it do that. If you want to retransmit to the application layer, just send it again, and that's it.
Okay. So I think then the question still is, should we put the same text for clients in there that is for servers already in there? But I think that's then a small change.
Yeah, I was going to say something else, but yeah, I think the conclusion then is just resend at the application layer.
Yeah. Okay.
Okay, so I think it was helpful.
Thank you very much. Then I will change the text, I think, a little bit again. Push a new version, and then maybe we can actually start the working group last call.
Yes. Congratulations.
If you could get it out, ideally, Andred, by Wednesday, not 2 days from now, but a week and 2 days from now. People should, not everyone, people travel. That's why it's 2 weeks long.
Yeah.
But most people should be back at their desks, and we can issue the last call.
Yeah.
We just make it a little longer. I mean, for weeks. Is it okay?
Yeah.
Oh, we'll make it 2 weeks because we won't be going over the meeting. It'll be a week from Wednesday. After we'll make it 2 weeks.
Okay.
Okay,
should we mine do first or yours? Then we can do the congestion control or request block and response delay first. Okay, so quickly going over that. That was a new draft that I pushed just before the last IETF during the hackathon, I think. So can go to the next. Basically, what we're trying to do, we have especially in federated radius environments, we have some supplicants or NASes that send excessive amounts of requests through our proxy fabric. And we know that these requests will never result in an access accept based on the supplied attributes. For example, because a user has a device that kept its configuration after the user left the institution. But this fact is only known to the home server. So the proxy fabric has to send the packets across the whole chain. The home server has to respond with no, go away. And some supplicants or NASes then say, oh, server told me to go away. I'll restart it immediately. Very stupid thing to do, but supplicants and NASes may do it. So at the Radius workshop we had just before last IETF, we talked a little bit about this and came up with the idea, maybe we can push the countermeasures for this load closer to the edge and delay replies or block requests. So for the delay reply, if a reply gets delayed closer to the edge, the radius ID on the hops following after that is immediately freed. And with delaying a reply, we can force the supplicant, if it's a multi round-trip authentication, to slow down. So we can even use this to deal with high-load situations where we can't handle all the packets that come in. And for the request block, functionality, the home server or any intermediate proxy that sees this can request a proxy that's earlier in the chain to preemptively block radius packets or immediately send a reject based on specific attributes of the radius packet instead of having to proxy this whole request across the whole proxy chain. Next slide. So the goal of the draft as it is right now, we don't want to solve every problem that we have with congestion, with misbehaving supplicants. So we don't care if missing responses have an effect on the proxy fabric. We may not be able to mitigate all active attacks. We are focusing on misbehaving clients that restart immediately or that are just otherwise filling up the proxy fabric. We want to have an ideally automated mitigation that just makes the radius proxy fabric a bit more robust so we don't have high spikes of traffic. So if a request to delay or reject is not satisfiable, maybe it's okay to just ignore it. It's a request, not an order, and we just try to make it a little bit better. So if a proxy, for example, also gets a request to block something, but the proxy says, well, if I would block this, I would block 90% of my traffic. That doesn't seem right. I won't follow it. Maybe it's okay. But what we do gain is that mitigation, especially if it's automated, can be much more targeted because for right now, manual filters, they have a maybe too high false positive rate. And they're just not really good countermeasures to actually solve the problem or mitigate the problem at the earliest stage possible. Next slide. So we had some discussions and questions on the mailing list. I've pulled some of those questions up from the mail thread. The mail thread is incredibly long. So the first question that we need to ask ourselves is this an actual problem that needs solving? So operators, if you can share details on what the observed issues are, what the current fixes are, and if not, why not? Are they actually implementable or good solutions? Then, of course, is the proposed solution an actual solution for the problem, or did I just think of something and it doesn't work anyway? Does it actually reduce load, or does the additional cache on proxies actually add more load than it would reduce? How do we deal with under and over blocking, all that? How should a home server or a proxy determine what should be blocked, what should be delayed? Should we do a radius routing protocol to solve some of the issues, like a radius flavored ICMP? Should we do trust router? Do we need more or less functionality? I think the thread diverged at some point. So I don't know, I think I have a next slide. So the questions, I think, is should we go forward with this document? Should this be included in a proxy BCP document? Should there be something completely different? I think this is the interesting questions for this document. So I can, I know if I should work on this or if I should throw it away and work on something else.
Margaret, we can't hear you.
Could we go back to the previous slide? Just where the questions were. I'll start with, for anyone who doesn't know, in my day job, I work with Internet2 to run the Edgerome service for the United States. And we see this problem happen somewhat frequently. It's not constant. It happens in incidents, and I'm not really at liberty, nor would I want to share any specific details, beyond things like the traffic that causes these incidents is usually doomed to failure. All right, the first one that we had was one user who had typed a comma instead of a dot in college.edu. They had typed college, edu. We've had other cases there. They happen when something's going on that this traffic for some reason is just doomed to failure. But there are a certain number of, we think it's all the way back to the supplicant for various hints that we have. We don't run the supplicants, but that the supplicant is retrying as soon as they receive a no response. So they get told no, they ask again, they get told no, they ask again, tens of thousands of times a minute from a single supplicant. And this can cause a variety of problems, especially if multiple users from a university for some reason are having the same problem. We don't think any of it's ever been an intentional attack. We think this is a weird non-feature of the protocol because there's no sort of exponential backoff. If in supplicants, if they, or in some supplicants, if they receive a no answer, they don't exponentially back off their reattempts. So yes, it's a real problem. Our current solution to the problem is rate limiting. There are various details to that I won't go into. I mean, this would take a long time. And there are different ways to rate limit, but ultimately they all have the problem that you're blocking someone without knowing really at our state whether the problem that they're having is transient and therefore the home server will eventually accept them, or whether the problem is permanent. And then there's also this other possibility that we would get some indication, a hint, have you know, from the home server that would tell us that it might make sense to block this user for this reason. That would have the benefit that sometimes we don't trigger rate limiting because people are using multiple paths, even though a lot of traffic may be going through to the home server. I don't know. In general, I like the idea, but in practice, I think we need a level of experimentation with it that would not start with writing I don't even think it has to be experimental document, but certainly would not start with writing a standards level document for it. Also, when you say, do we need a radius routing protocol? ICMP is not in my mind a routing protocol. I brought up that particular suggestion, and I was suggesting that rather than developing 4 or 5 different signaling protocols that use different attributes, and you not sure what to, each one is taken individually, and you're not sure what to do if you get more than one, that it would be nice to put them together in one attribute, a structured set of things that are going on, so that you could define stuff like what happens if more than one of those flags is set, or whatever. That was not a suggestion to write a routing protocol. I wrote the ABFAB trust router protocol, and I'm not sure it solves this problem. So I think it solves other problems, but I would not suggest it as a solution to this problem. So that's
I just included it because it was in the thread. At some point, the thread diverged to, should we do a radius routing protocol?
There is that question, should we do one? And if people ever decide they need one, I happen to know of one. But in the meantime, I don't think that's something we should do to solve this problem.
Alan?
Okay. This is Alan. Yeah. People have talked about a radius routing protocol for 15 or 20 years. I don't think it'll ever happen, but it's a nice idea. In terms of this document, I think it's a good idea. One of the outcomes of the Radius conference in March, one of the operators there was telling me that 90 to 99% of their traffic is rejects. So getting rid of those would be enormously beneficial. I think we can probably do it without too much signaling. But to Margaret's point, it probably also would be useful to allow these attributes to go in a protocol error response. But I do think this document is probably separate to the protocol error one because it solves a specific signaling problem with rejects. And the protocol error, maybe that other one should be called improved signaling, addresses a more general signaling issue.
Hello, it's me again. So one thing I would like to see in this document, and this is more getting into the actual implementation of it, is so at the moment you can block at the, well, it's designed for blocking at the proxy level based on certain attributes. What would be useful is somehow to signal this client is misbehaving, stop responding to them. That could maybe eventually even be passed down to the network port and say just block that port for 5 minutes. I know this is a bit difficult because we don't want to be handling like MAC addresses all the way across to the home server for that the home server then to say this MAC address is being naughty. But we do have the chargeable user identifier, and then somehow we could then say, okay, well, if you can backtrack what that chargeable user identifier should be is mapped to which physical device, just tell that physical device to go away for a bit.
Yeah, one of the issues with that is that Radius does not run all the way back to the physical device.
Yes.
EAP does, and there's a proposal called EAP Die that does exactly what you're talking about.
So I don't mean this goes all the way back to the physical device. I mean this goes back to the access device that the physical device is trying to connect to. So the network switch, the Wi-Fi access point, and
the NAS, yeah.
Yeah. And then that can just say, okay, well, you're misbehaving. I'm just not going to answer your Wi-Fi association requests.
Theoretically, for right now, if a NAS actually understands the attributes that we sent there, the NAS could already act that way.
Right.
But
yeah,
useful suggestion, we'll include it.
Well, Radius stops at the NAS. Radius does not go to the access point to block a port. We'd have to do that at the EAP level.
Yeah, what I'm suggesting is getting NASs to implement this will be annoying, but there may be other protocols which NASs support for blocking ports, and therefore that could be implemented by the Radius server of the, the NAS talks to some local proxy, and that local proxy could understand this block request and then turn it into a request to the network switch or whatever to block that port.
Good idea. Thank you. Okay, I think we're at time. So thank you very much for your input.
So Alan, we have a little time, so please be quick.
I'll talk very quickly. Yes, next slide. So this is something that came out of a bunch of experience with proxying. As Margaret noted, 2865 says, yeah, you can do proxying, and then runs away. 30 years later, maybe we should talk about it. Next slide. In addition to signaling issues, there are a lot of issues with proxying. Every time something comes up, either implementation, deployment, whatever, I've been adding it to a list, and that's in the proxy BCP. A lot of people have come up with ad hoc solutions, which may or may not work. It'd be good to write down the best of those. Next slide. So there is a very long list of problems that people run into. What the problem is, what effect it has on the network, the recommended solution. We're not going to go through this in detail. I have sent the document around to as many people as I can who I think might have input. As is typical with Radius, not everyone has input, but I will keep pushing that. Next subject, next slide. So that's the list. In the last week, I've added a few more. There's a whole bunch of problems. So it's good to write these down and write down what we can do and what we cannot do about them. Because what happens if we don't is people come up with their own solutions, and those will not have the benefit of 30 years of experience of people doing it the wrong way and then figuring out the right way. Next slide. Comments. So it's very, very high level right now, mainly outline. It needs filling out, but the basic outline is there, and it takes input from multiple implementations and operators of high load proxy environments. So I believe if we write it down and people pay attention to it and start using it, radius proxying will get somewhat more manageable, but not completely, because it's radius. Let's be realistic. Yeah, so this is part of the outcome of that conference is really the idea that we should have these three documents: the congestion control, the protocol error, and the proxying. And I think there's no quantitative data because people haven't implemented it, but the general idea is that if we do all three of them, it should be a lot better. Questions? No, everyone's in agreement. Yay.
It's a good.
Yeah. Thank you. Next one. Protocol error. This one may be better described as better signaling. Next slide. So there's a whole bunch of signaling issues in Radius. There are situations, specifically a counting request, where you are required to discard the request you receive. You're up, you may be proxying other things, but for some reason you just take this request and you throw it on the floor and you pretend you never received it. That seems bad. It causes all kinds of issues. It would be better to have a radius layer signal saying, I know I received this, but I can't do anything with it. So I'm still up, but please send the packet somewhere else. That was originally defined in 7930, which is the large packets, so larger than 4K radius packets. Not many people seem to have implemented that. But if you look at other situations, there are many, many situations where implementations will silently discard packets. And that's a problem. So there is no protocol message saying, I can't do this. There's request, ack, knack, but not, I can't do this. The next slide. So the draft explains in a lot of detail. So 7930 basically said, protocol error exists. Here's how to encode it. That's it. This draft goes into all those situations where packets are discarded, why people do it, notes that in many cases people are doing it where it's not recommended, and discusses how protocol error would help. Next slide. So we have a lot more detail here, as I said, and the hope is that we can not just add this to implementations. Specifically, proxies would benefit the most from this. But it's not just defining the packet, it's explaining why you need it. Because there's a lot of things out there where people just do the obvious thing and not the thing which is a little more standard / stable. Next slide. So we're not proposing to do any kind of link layer negotiation. You should be able to configure the client and the server to either send or accept it. It's always safe to send it because old clients will ignore it. And so, yeah, the document addresses longstanding issues with implementations, and maybe it would be better titled improved radius signaling, because that would get the message across more that this isn't just a new packet type for some weird reason. It's if you have inter-server signaling issues, you improve the signaling. Next slide. This one has a lot more content fleshed out than the proxy BCP. It needs a little more, but I'm hoping that there isn't a lot of contentious discussion around this. So hopefully it could be pretty quick, he said optimistically, like all the other documents. Questions?
I have a comment. One is I totally agree with you about what came out of the conference regarding the three things we needed to do, and I definitely think we should do them. The other though is here's the reason why I want an ICMP I like improved signaling. It doesn't have to be called certainly ICMP, but an ICMP like signaling protocol, because I don't want a situation where I've got somebody spamming me with all this traffic. The proxy at the edge doesn't implement any of this, and I am sending 2 messages back every time it happens. What went wrong? And please stop. What went wrong? And please stop. I want those to be 2 bits in the same packet.
Yes. So, yeah, this wouldn't change the request reply nature, but there's a bunch of error cause attributes to find or values to find where you can say whether this error is temporary, permanent, and what should happen. The proposal in this document is to add a few more, giving a little more information about what to do.
But there's also the notion that adding as little, I think these things are going to happen frequently together, that we're going to say something went wrong and please stop sending the same request over and over. And to me, the stop sending should just be a bit in this something went wrong message. And then the something went wrong attribute. I don't even want to send 2 attributes, because anytime I make packets bigger, I can run into MTU and fragmentation issues. So
yeah, these are the replies, so they're all pretty small. I think there's no reason why we couldn't have the congestion control attributes in the protocol error reply. I think that would be useful too, because that is arguably more signaling, but I think there is value in still putting them in the access reject. And the protocol error discussions here also solve other issues that are not the congestion control. Things like, hey, I'm up, but my accounting database is down, so please send accounting traffic somewhere else, but you can continue to send authentication packets to me. Because right now what happens, if a server receives multiple kinds of packets, or even packets for multiple destinations, it just randomly doesn't reply to some of them. And it would be good to say, oh, you sent me something for example.com and I forwarded it, great. But you sent me something for example.org and protocol error, their server's down. Please send those packets somewhere else. So they solve overlapping and related, but different issues, I think.
Elliot?
Hey, good afternoon, everyone. Alan, you wrote a draft a while ago about capabilities exchange. For those who don't know, I think you wrote it in it was 2012 or something, right?
Yeah.
And I'm wondering how much of this is related to capabilities exchange versus signaling. It's just a question. I won't claim to be the radius expert on this. I'm just curious where you think the line is.
I would say the signaling is per authentication request. If we focus just on authentication, you do need to be able to signal, I received this packet, but I can't do anything with it. Separately, the capabilities exchange is whether or not either end will understand that signal and do anything with it. If I remember going back to 2012, there was a lot of discussion about capabilities exchange and radius. And the conclusion at the time was no one really agreed on what it could do. The slightly mean subtext was it was hard and not everyone wanted to implement it, but there wasn't consensus to move forward with it. And I don't think it offered enough value for people to do it. It was difficult to implement, and it was difficult to describe exactly what those capabilities are. So it's easier, I think, just to ignore that and just go with a per packet response. There's still some things implementations can do about it. Caching configuration, right? I talk to your administrator and we agree that these servers have these capabilities, and that's generally good enough. Jenfrid.
Yeah, I just wanted to add the comment that protocol error is intended to be per hop. So we need to keep in mind what signals are on a hop by hop basis, such as I can't deal with accounting right now, please send it to the other proxy. So this is actually a hop by hop. And then there is the end-to-end signaling, like client is misbehaving, make him go away. So there are two different sets of problems. It's just something to keep in mind. I think this document is needed, definitely.
Okay.
Keep answer packets that you would throw away.
Yeah.
Just causes problems.
Yeah. Okay.
Okay, thank you. And we have one presentation left and 3 minutes. So if Changwan, if you can do this quick, then please do this quick.
Okay, I just want to verify it's useful and feasible to use quick. So next slide, please. So we know the TCP is used as a transport protocol for radius in a scenario such as the inter-domain communication between proxies, and the quick could replace TCP as the transport protocol for radius for the following reasons. Next. So the quick has high efficiency, and the quick can support multiple simultaneous streams to carry data, and it could avoid head-of-line blocking and improve overall performance. And the ability of Quick to handle connection migrations seamlessly could enhance user mobility without disturbing radius authentication sessions. And the Quick could provide transport security with built-in encryption and authentication. Next slide. So we consider the connection establishment. Radius or Quick support is indicated by selecting ALPN, the TLS handshake, and the radius client is the initiator of the Quick connection, and the server is the acceptor. And during the next slide, please. And we need a bidirectional stream between client and server, because if there is a request from client to server, the server need to respond to the packet. And if there are a large number of radius requests packets, and the Quick can provide multiple streams between client and server. Next slide. It can also provide TLS handshake or third-party authentication. Next. And here are some operational consideration. So we need a configuration mechanism for the radius of Quick, and Quick is a reliable transport if there is no response to a radius packet of one connection. And the packets must not be retransmitted over different Quick connection. Next slide. So we also have annual considerations with the following information, and we also need to require Selena to reserve a UDP port for the radius of Quick. Next slide. And we request more review to improve the draft, and any comments are welcome. And I'm Shengyan Yue. Thank you.
Thank you, Margaret. But we have no time. But please, since you're in the queue, please.
So thank you for presenting this. I think that I don't think it should replace TCP because I think there are definitely cases where people are going to want to do TLS over TCP. But I do think it would be useful as an option, QUIC being a valid transport. I wonder, has TLS been defined over QUIC? And do we really need a significantly different draft for TLS over QUIC than we would for the current TLS?
Except for the security, I think QUIC can also have more benefits compared to TCP. For example, it can provide multiple streams, and it has a lower RTT delay, and so on. So I think it is useful to use the QUIC as a transport protocol.
So, Margaret, maybe I can help answer this. TLS in QUIC is something you are not allowed to touch. It is baked into QUIC. So you can't do anything with the TLS. That is just part of the QUIC protocol. The reason that this draft will have to exist as something different is because QUIC doesn't just provide a packet interface. You don't put data in, it comes out the other end. You have streams. So this draft needs to exist to define how radius requests are mapped to QUIC streams.
Okay. Yeah, I mean, I think it's a useful thing to do, probably, experimentals begin with or something. But I think that, QUIC exists and we should know how to run radius over it. I don't think this should replace running radius over TLS and TCP, aka RADSEC we run today. I don't think that makes, you can't just wave your hand and make that happen. But I think that should be an option.
Okay.
So my question was, you mentioned connection mobility, and I would like to understand how this comes into radius, because my understanding of at least how radius is deployed is you have a fixed networking device and a fixed access control server, and these aren't changing IP addresses. If they're exactly. If they're changing IP addresses, then something has probably gone horrifically wrong. So what situation did you come across where connection mobility was actually useful for this?
So I think maybe the user change its network from Wi-Fi or to 5G.
But the user is never talking radius. The radius is between different parts of the network infrastructure.
So maybe the client will change its IP address, maybe.
Yes, but if a user changes its IP address, then they will probably have to do a new EAP session to connect to the new network. What connection mobility would be useful for is if the Wi-Fi access point or something somehow moves IP address, which I don't think we want to be happening.
Since we are already
sorry.
past the time, I think the discussion is interesting, and so we can continue on the list.
Yes.
Just bring this question to the list.
So welcome to talk with me in the mail list.
Thank you. So thank you all for productive meeting. Unfortunately, it's short, but I think we were able to do most of the things, and so thank you all.
Thank you.